Good morning, everybody. This is a live update as we have another threat of severe weather and isolated tornadoes across the upper Midwest. It's that standard hotspot there from northeastern Iowa up through northwestern Wisconsin. And honestly, the preliminary glance at this setup makes me favor northwestern Wisconsin just a bit. But look at this massive open wave here, big time trough. Starts to shear out as it turns into a bit of a bowling ball. The base of that trough definitely consolidates, tries to close off a bit as that heads toward the southern Appalachians, bringing with it some cold temperatures and definitely some winds, fall-like conditions across the central and southern Appalachians. But today looks like quite a threat of severe weather, and I do think that western Wisconsin looks to be the most favorable. Here you can see this massive trough replaced by yet another ridge. This definitely provided a bit of relief to the Pacific Northwest as well. Kind of a prolonged atmospheric river event. And it does look like this ridge that builds in to the western and central U.S. behind this system is relatively short-lived, as we do have another trough coming in to the Pacific Northwest back behind it. This loop goes from basically right now, initializing this morning, through midweek toward the end of Wednesday. I can, of course, loop that a lot longer, but I first want to show you the 850 winds here. Let me see if I could even loop this, and then we can show you the evolution of that low-level jet as it cruises across the upper Midwest. And again, this forecast period is from this morning. There you can see that low-level jet ramping up across western Wisconsin, and then it lifts off into eastern Canada as that bowling ball of an upper-level system slides off to the southeast toward the toward the central and southern Appalachians. So we are going to break down this severe weather threat across the upper Midwest today. And there you can see that. What a nice textbook trough ejection. The timing relative to the life cycle of this trough. You can see it's a large open wave. You get a little bit of the base of that trough definitely dominating. A little segment also causing us severe weather today. It tries to eject northeast toward Ontario. Bring it with it, that low-level jet. Still working on this mouse. It's a little bit sensitive. Sometimes it'll automatically click. So let's zoom in a little bit closer to our target area right now here of the upper Midwest. If I can work this mouse, I need to adjust the settings and make it a little bit less sensitive. So again, there's that trough ejection that we broke down. Let's go a little bit closer to the upper Midwest here and break down this low-level jet. And instead of doing a loop, I'm going to do each individual image. Gives us a little bit more control. So here it is this morning. And this is that low-level jet that we were talking about. This is the 3-kilometer NAM here. And this morning, the low-level jet is maximized through eastern Kansas into eastern Nebraska, western Iowa as well. But watch as we step forward through time. We'll go at 2-hour increments up to 15Z, late morning time period. And the low-level jet creates low-level wind shear that is pivotal to cause tornadoes. So generally speaking, over my 25 years of storm chasing, very rarely have I seen a tornado when 1-kilometer winds are less than about 20 knots. So really that is kind of the benchmark that you look for to have a sufficiently strong low-level jet to generate wind shear that is supportive of tornadoes. So this is the midday hour, about 1 p.m. actually, Central Time and Central Daylight Time. And this shows you kind of the peak mixing period. And mixing is when the surface temperatures heat up to a point that you start to mix down dry air aloft. You mix down that faster low-level jet just above the surface down to the ground. And when you average out those parameters across the boundary layer, then it leads to a reduction in the surface dew point. It leads to a weakening of the low-level jet a little bit. But then it starts to ramp up as you go through the afternoon hours, especially during the late afternoon into the evening hours. That's why we call that time period the magic hour, right at about 0Z. That's because that low-level jet begins to increase. You still have enough instability, and the cap is shallow, sufficiently shallow to where you can still, that a strong low-level mesocyclone is able to drill down to the surface and become surface-based and tap in to that deeper moisture. So now we're at peak mixing. So let's take a look at as we progress through the afternoon hours here. So here you go to 16Z. Let's jump up. This is actually 19Z. Let's jump up to 20Z, which is 2 p.m. Central Time. And it looks like that low-level jet trailing down through eastern Iowa is weakening a little bit. It's not starting to reinvigorate yet. But look it up here across northwestern Wisconsin. You start to get those 40 knot values. You get a more backed low-level jet, meaning that's a little bit more southerly across northern Wisconsin. You even got a 50 knot barb up there just to the south of Ashland, Wisconsin. And this is also a little bit close to that early piece of energy, that jet streak that is ejecting toward Ontario and Quebec eventually as the base of the trough begins to consolidate when it approaches the central and southern Appalachians, the middle to later portion of this week. But you can definitely see these stronger magnitudes starting to shift to the north with time. And that's why I favor northwestern Wisconsin a bit. I do think that there is a tornado threat, though, further south through central and northeastern Iowa, but you can see that the low-level jet down south is just a little bit more diffuse. But you still have 30 to 35 knot magnitudes there at 850, but then it ramps up across northwestern Wisconsin, and that's where your greatest low-level wind shear is going to be located between the 21Z and 0Z magic hour, 4 and 7 p.m., Central Daylight Time. But you can see this 40-knot low-level jet out ahead of these storms. The frontal boundary is also more north-south across northwestern Wisconsin, and that's going to provide the ability for these storms to move off of the front or at least not be undercut by it. You can see that these upper-level winds shifting up to 500 millibars here out of the southwest at about 40 knots. So with that front oriented a little bit more north-south, that should create for the ability for those storms to be able to move off of that front across northwestern Wisconsin. Sorry, I just slid a little bit down to the south there. Oh, we don't want to do that. Sometimes this thing automatically clicks the mouse. Still trying to figure out and get used to this new laptop. So let's take a look now at the dew points as well here by 21Z. This is 22Z to be fair, 5 p.m. Central Time. And you've got those near 70 dew points streaming all the way up into northwestern Wisconsin. That's the nose of that instability axis up into northwestern Wisconsin, the nose of those 70 dew points. And that's the generally speaking, if you target the nose of those moisture axes, you're likely going to see a lot of tornadoes. And one negative factor I can see with this setup is you don't have a very prominent elevated mix layer. Usually in the mid-levels of the troposphere, you'd see a little bit of a dry layer here, which would help to enhance those lapse rates, boost the CAPE a little bit. Also have a little bit of cloud cover near the nose of that instability axis. That dew point line in green and the temperature line are pretty close to being overlapped there. So cloud cover could be an issue here across north, at least in the northern section of the target area. Moisture, though, certainly not a concern at all. We're going to have plenty of moisture out here available for these storms to thrive. We're also going to look at the convective mode as well, and you can see that even the 3-kilometer NAM, which isn't the best model for breaking down convective mode, but it does look like it maintains cellular convection here across northwestern Wisconsin, and that's where that front is a little bit more north-south. You have those southwesterly mid-tropospheric winds that should allow these storms to move off that front, tap into that 40 to 50 knot low-level jet here across northwestern Wisconsin, and definitely could develop a pretty robust tornado potential there. And that tornado potential could extend all the way down into Iowa as well, even central Iowa along that front, even though you do have a little bit more of a diffuse low-level jet, those winds of about 30 knots. I still do anticipate those storms to have a little bit more of a easterly storm motion, and it does look like near 22Z you get a bit of a reinvigoration of that low-level jet near the southern edge here, all the way back into central Iowa, central northeastern Iowa. You get a bit of a reinvigoration of that low-level jet, and I do think that there is certainly a threat of tornadoes all the way down into central Iowa. So then we go to 23Z. This is at 6 p.m. Low-level jet, really healthy from northwestern Wisconsin all the way down through eastern Iowa. So I do think that eastern Iowa has a very decent chance of tornadoes here. Definitely that low-level jet is intensifying as you go to 6 p.m. and closer to 7 p.m. Looks like the maximum in that low-level jet, northeastern Iowa into western Wisconsin, all the way up to Lake Superior. There is likely going to be some cloud cover that could maybe hinder that tornado threat across the northern section of Wisconsin. But overall, I do think that there is a pretty high chance of a tornado threat today. Maximized across central and western Wisconsin down into northeastern Iowa within the core of that low-level jet. So let's look at the 0 to 1 kilometer storm relative helicity here. And you can see that the best 0 to 1 kilometer shear is across northwestern Wisconsin. That is consistent with our eyeballing initially of these models. And that's where I do think that there is a pretty decent chance of a tornado, maybe all the way up to the shores of Lake Superior even there. You have about 250 to 300 0 to 1 kilometer storm relative helicity. More than sufficient to generate that tornado threat, and that favorable low-level shear for tornadoes goes all the way up into the western upper peninsula of Michigan, west of the Keweenaw Peninsula out there, Ironwood area, north central Wisconsin. This is at 0Z. Let's take a look and see what these storms are doing by this time as well. So I am seeing a pretty decent shot at tornado potential across northwestern Wisconsin. I would be chasing this setup, but I got some big problems with logistics right now. Dominator Fore is in the shop. The exhaust header parts for that aren't going to be shipped until the second week of October. I've also got a varsity tutors class coming up on September 27. And I have our practice class tomorrow, September 21st. So I'm going to be preparing that material today. This next class is going to be how to be a storm chaser, what it's like to be a storm chaser, chasing down tornadoes and hurricanes. I'm going to run down the process that we use for tracking down these tornadoes, which I'm really going through right now, developing that target area. And it does, even though this does look quite linear into eastern Iowa, you can still see that there likely will be some embedded supercell structures, even at 7 p.m. here, down into central and eastern Iowa, up into the southeastern corner of Minnesota, western Wisconsin. You start to lose the instability a little bit as that low-level jet increases and that low-level shear, 0 to 1 kilometer helicity increases above 250 up there. You get a little bit of cloud cover. Boundary layer tends to decouple a little bit, and I still think there's going to be some embedded tornadoes, though, within this squall line here that will evolve across northwestern Wisconsin, down through eastern Iowa, all the way down through portions of Missouri as well. So I do think there is likely going to be some tornadoes embedded within this line as that low-level jet continues to intensify out ahead of it. This is at 1 o'clock, or 1Z, so 8 p.m. Central Time, and you can still see this low-level jet holding steady up from northeastern Iowa up through central Wisconsin, all the way up to the Lake Superior shoreline. Western Upper Peninsula of Michigan even has that 40 to 50 knot low-level jet up there. So definitely quite a favorable low-level kinematics for a tornado threat. So let's take a look at the surface-based CAPE here at this time. This is at 1Z. So let's take it a little bit earlier in the evening. And this is at 22Z. And this shows that even though the strongest low-level wind shear is located across northwestern Wisconsin, the instability is going to be the limiting factor up there, and there could be quite a bit of cloud cover near the nose of that instability axis. You get a lot less cloud cover as you go further south across southeastern Minnesota, northeastern Iowa, back into central Iowa. A lot more instability to work with. Likely a more favorable elevated mix layer down into central Iowa too. We can look at a sounding here, and you can see a lot more dry air at about 500 millibars up there. That acts to steepen those lapse rates in the mid-levels of the atmosphere. That red line is temperature, green line there is dew point, and so the drier the mid and upper troposphere up here, the steeper the lapse rates. You get a lot more cooling then in the mid-levels of the atmosphere, and then as you go from the low levels, look at those steep lapse rates too down into central Iowa with the surface temperatures warming up into the low to mid-80s over basically 70 to the low 70s dew points, plenty of low-level moisture, steep low-level lapse rates there. And a little bit further south into Iowa, you get a better elevated mix layer there, as you can see in this sounding. Well, let me, you can see the hodograph on this. So let me shimmy this image off to the left, and then I can show you what I was describing. There you go. That green line there, that's dew point. The red line is temperature. So when you get this dry area here in the mid-levels of the troposphere, that's an elevated mix layer. Sometimes it can occur a little bit lower in the troposphere, even a little closer to 700 millibars. But those will act to steepen those lapse rates within that layer. A drier environment tends to be a little bit cooler up here aloft. And then over top, the warm temperatures and the deep moisture here at the low levels, that will act to increase the instability between the surface and the mid-levels of the atmosphere, and that's why we have a lot more CAPE down there. You can see those southerly low-level jet at about 35 to 40 knots, flipping over due southwesterly at 500. Mid-level jet streak there of 40 knots. And that creates quite a favorable hodograph even down into central Iowa, even down toward Des Moines. Des Moines, I think you've got even a realistic tornado threat later on today. Even though those higher tornado probabilities are located across northeastern Iowa into northwestern Wisconsin, I think that there's greater instability further south. And looking at those hodographs within this pipe here of instability, 2300 surface-based cape, that's a favorable hodograph. And you do have a little bit more of an easterly storm motion, east-northeast, maybe due northeast there, but plenty of wind shear carved out of that hodograph. The hodograph right now is a little bit just underneath my head. Let me slide this over a little bit so I could show you the kinematics here as well. That's what the hodographs are used to show. Basically, just below my head there, you can see that hodograph. And the more hook-shaped that hodograph is, the more storm relative helicity is available in the environment available to these storms. And basically the area enclosed within this storm motion vector and the hodograph there, that area, the larger that area is, the larger the helicity within that layer. And so you can kind of break down the storm motion vector and the 0 to 1 kilometer shear vector, and you want them to be relatively close to 90 degrees. And look at that angle between this line, which is the 0 to 1 kilometer shear vector in the hodograph, and this is the storm motion vector right there that it makes with that low-level shear vector. The actual storm motion vector is like this, southwest to northeast. But you draw a line back to the surface wind, which is due south at 20 knots there, and you're very close to a 90-degree critical angle, which my old office mates back at the University of Oklahoma, good friends of mine, Don Giuliano and John Esterheld, actually invented that critical angle there, realizing that streamwise vorticity and the low levels of the atmosphere are very important to generate tornadoes. And when you have this storm motion vector that is perpendicular to the 0 to 1 kilometer shear vector like that, you're basically pulling in those horizontally rotating tubes within that layer. The storm motion is moving perpendicular to those tubes, and it's very effective then at stretching those into the vertical and then leading to the development of vertical vorticity or tornado genesis. And sometimes you can see those streamwise vorticity pipes just wrapping into the mesocyclone, often streaming in from the north or from the east along the gradient of the forward flank gust front. But it pulled the updraft of the mesocyclone, that giant rotating vacuum cleaner of a supercell storm. When that pulls in that streamwise vorticity, it's able to stretch it up into the vertical. That's when you get the intensification of the low-level mesocyclone, and that's when you can get cross-isobaric flow. Clear slots will cut into the middle of that mesocyclone. You tighten up the low-level rotation on the cyclonic side of that clear slot, and that's when you start to get tornadoes. And you can see pretty robust cape all the way down into eastern Kansas. Not as favorable low-level shear, though, down in eastern Kansas. And we look at that hodograph, though, and it still is supportive of tornadoes. You have a more due easterly storm motion at about 25 knots, a bit of a capping inversion down there in eastern Kansas, more veered westerly component winds from the surface all the way up to 500 millibars. But still, you do have a hodograph that is marginally supportive of tornadoes, even all the way down into eastern Kansas. And I do expect convective initiation down there as well. Let me make sure I still have this organized properly on here. Hopefully I'm still live even. Let's take a look really quickly at the HRRR, which I'm assuming still has its dry bias, and it definitely does. Look at that HRRR model, mixing out these dew points big time across central and eastern Iowa. Likely an overmixing there as well. The moisture definitely looks deep, even near the moisture nose up into northwestern Wisconsin. Cloud cover, I think, is going to impede the instability a little bit across northwestern Wisconsin, but it shouldn't that much. And so let's take a look at the dew points and see this reason for the low cape. And it mixes out dew points into the low 60s out here ahead of this front. Northwestern Wisconsin, southeastern Minnesota, eastern Iowa. You get a couple little blobs there of mid to upper 60s, but what a difference between these two models, the HRRR and the 3-kilometer NAM. I think the 3-kilometer NAM has a much better handle on the low-level moisture situation. So it's almost worth it just to throw this model out, unless you think that that mixing will happen. And in that case, it's going to be more of a linear, I think that runaway evaporation will happen beneath with this low-level sounding, with this low-level moisture, meager low-level moisture, over-mixing by the HRRR. That's going to lead to just a pure squall line out there. And if those dew points do over-mix like that compared to the 3-kilometer NAM, or if the HRRR is remotely accurate, then you'll likely see a little bit lesser of a tornado threat. So I think that a lot of the storm chasers that are sitting today's storm chase out are probably basing it on the moisture situation, purely on the HRRR. I know that's a favorite model of storm chasers, but you got to be careful because it definitely has that dry bias, and it seems to be on display here with this setup across the upper Midwest a bit. Although that last upper Midwest setup, definitely those moisture shortages were realized that were indicated by the HRRR, so there is a chance that if we mix down to the low 60s, low to mid 60s, then that tornado threat will be less and it'll be more of a damaging windbag type of an event. But this is at 0Z by the HRRR. Definitely ejects that strongest low-level shear off to the northeast across northern Wisconsin. 50-knot low-level jet from the shores of Lake Superior all the way down to the southeastern corner of Minnesota, where it starts to weaken just a bit. But the La Crosse area could see some tornado potential as well. I tend to believe the 3-kilometer NAM here, especially in the upper Midwest. That moisture, based on those forecast soundings, really doesn't look that shallow. So I don't think that we're going to see that crazy runaway mixing that the HRRR is showing. You can see that 64, but even with an 80 over 64, that's still sub 20 degree dew point spreads. Really, you want a dew point spread below about 20 to 25 degrees to have cloud bases that are sufficiently low to realize a tornado threat. And that is a pretty favorable hodograph with that 1 kilometer wind of about 45 knots. Your surface wind at about 15 knots out of the due south. This is the most favorable hodograph that we've seen so far in a forecast hodograph type of a perspective. So let me lower this a little bit below my head so that you can see that forecast hodograph. And look at that classic hook shape, near 90 degree critical angle, 60 degrees, plenty high. Basically, if you have a greater than about 50 to 60 degree critical angle, a lot of times when you have a really strong low-level jet of 40 to 50 knots, that really long 0 to 1 kilometer shear vector is able to overcompensate for a sub 90 degree critical angle, and you can still get big time 0 to 1 kilometer wind shear. This particular hodograph here shows 307 0 to 1 kilometer storm relative helicity. This one was picked up in northwestern Wisconsin, but there again is that relatively meager elevated mix layer on this sounding. And let me slide that over again. Usually for big tornado events to happen further east, you need to bring that elevated mix layer east as well. You need to bring aspects of Great Plains, Tornado Alley, tornado outbreaks. You need to bring aspects of those outbreaks further east. Basically, you're taking the west, bringing it east, and that includes the elevated mix layer, which emanates off of the Mexican Plateau or the Southern Rockies, the higher terrain there to the west. And that elevated mix layer goes over top that heat and moisture and creates instability in Cape. And that's why Tornado Alley is one of the most prolific tornado-producing locations anywhere in the world, because you have that elevated mix layer generating machine upstream. That is the Southern Rockies into the Mexican Plateau. But in this case, in far northern Wisconsin, you kind of have a meager elevated mix layer there. Just a little carrot, a little dry air there coming in at about 6 kilometers. And you do get a little of this weird shape, just a little bit of veering up above 500 millibars, or excuse me, a little bit of backing above 500 millibars. You got to wonder if that'll slow down those storms just a little bit with a surging cold front to favor a more linear mode. But anytime you have a 40 to 50 knot low-level jet out ahead of a convective line like this, you're likely going to get tornadoes embedded within that circulation as well. So Ashland down to La Crosse, northeastern Iowa, even back toward Des Moines. Stay tuned to those watches and warnings. I think down near Des Moines it's going to be more of a 3, 4, 5 p.m. type of event, and then shifting toward La Crosse up to Ashland, northwestern Wisconsin by about 6, 7, 8, 9 p.m. But it's going to start early up north as well. And overall, the HRRR, I think, doesn't have the greatest handle on moisture return. Let's take a look at the RAP really quick. One of my favorite tools that I will use to chase storms. And I'm going to be breaking down these tools today in preparation for my Varsity Tutors class coming up on September 27. as well. This main surface low with this event is going to be up in Ontario with that initial jet streak that is ejecting off to the northeast. Let me square this on our target area. This is the RAP model here. Maybe we can shift this a little bit off to the east as well. Let me change regions. Well, not the best region layout for convenience sake, but we can still access our target area. Really what I'm trying to see is the evolution of the instability axis. I want to see if the RAP model also has these negatives. You gotta be kidding me. I'm just not. I'm so used to using a Mac now after all these years. And sometimes it can be a little bit of a struggle. There we go. So that cape is already building here this morning. Already cape in excess of 1,000 across eastern Iowa, nosing up into southeastern Minnesota there, and that's only going to increase as we go through the day today. I also want to show a little further north. Let me make this a little bit smaller so that I can also show northern Wisconsin, because obviously we want to see how far north also that instability axis goes. So you can see quite a bit of convective inhibition there across central and northern Wisconsin. And stepping forward 4 hours, this is, that would be 18Z. Let's go to 20Z. Not sure if you can see that, but look at that nosing into western Wisconsin there. One thing that I'm seeing here with the RAP is it looks like it tries to keep most of that convection behind that surging front a bit. There we go. That's how you zoom. Does look like a lot of the convection is just a little bit post-frontal there. But look at that convective explosion all the way back toward Des Moines, where you have that 2,000 to 2,500 axis of instability. Not as much instability off into northwestern Wisconsin, but you do have those more backed surface winds there that will enhance that low-level wind shear, low-level SRH up into the northern section of the target area. Let's take a look at the effective helicity here. This mouse is so frustrating. There we go. So it looks like even down into central Iowa with those more veered surface winds, a little bit more westerly component, at least by 20Z, not as much low-level shear available to those storms back into central Iowa. You have about 100 to 125 0 to 1 kilometer shear. But you can start to see that 200 blob there across northwestern Wisconsin begin to expand. And after 20Z, especially after 21Z, you're really going to see that low-level wind shear enhance across western Wisconsin. But definitely a negative that I'm seeing with this setup is a lot of the most robust convection is happening just behind that cold front. But it is a north-south oriented cold front, so those southwest and northeast storm motions should be fairly effective at moving off of that front. Let's take a look at the dew points here on the RAP model. It's got those 68 dew points out there. So the RAP is a little bit closer to the HRRR model with those low to mid 60s dew points, at least in the northern part of that instability axis. Further off to the south, though, from northeastern Iowa off into central Iowa, you do get those upper 60s dew points. You get about an 84, 86 over 65. So that should be more than sufficient to generate enough instability down there. let's take a look at the surface map right now. So I think what's going to happen is you're just going to have a fast-moving fall season squall line. Well, you got 66, 65 dew points, some 64s up here, and then you get your pool of 70s. Not the greatest surface map there. Boy, quite a bit of model discrepancy here amongst the 12Z short fuse forecast models. The 3-kilometer NAM shows a little bit more substantial of a tornado threat. Northwestern Wisconsin back into northeastern Iowa. However, the HRRR shows a little bit more mixing happening. Shows that low-level jet focusing up on the Wisconsin target, basically from La Crosse up toward the Ashland area. But the 3-kilometer NAM definitely maintains a nice low-level jet, 30 to 40 knot low-level jet across eastern Iowa there, within that eastern Iowa axis there, 40 to 50 knots. Stronger flow, though, northeastern Iowa, southeastern corner of Minnesota into western Wisconsin. A little bit closer to that surface low, which is off to the north of Lake Superior up into Canada, Ontario up there. But a nice pressure trough all the way down that front. Northwesterly is back behind it. Definitely kind of a surging fall season front here. Temperatures fall into the 50s back behind it, up into the 70s out ahead of it, pushing 80 by 0Z as well. So let's loop this really quick just so I could show you this beautiful fall season cold front through the upper Midwest. And the Storm Prediction Center did upgrade those tornado probabilities. Looks like there's a little bit of a kink in that front that tries to slide east-southeast through northern Iowa. And just to the north of that kink, that little ripple within the front, could act as like a little bit of a surface pressure perturbation there, and we'll have to keep an eye on that. There you can see it warming up, rebounding. So here's the front. There's that ripple, a little bit of a meso low moving through northeastern Iowa. Keep an eye on that. You could get some embedded tornado warnings within this squall line. By tomorrow morning, it moves through lower Michigan. Temperatures fall into the 50s back behind it. Maybe some 40s as well across portions of the northern plains there, across Minnesota. Even Iowa could see some 40s back behind this front. But watch that little ripple. Maybe near and just to the south of that, you could get a more north-south orientation to that front. And we could get a little bit of some enhanced low-level shear there as well. Let's watch the moisture. Let's loop the moisture now in the 3-kilometer NAM. And look at this, near 70 dew point going all the way up into northwestern Wisconsin. If that happens, then the tornado threat is going to be a little bit higher if the 3-kilometer NAM is more accurate. But if the HRRR is accurate, I still think we're going to get those 20-degree dew point spreads. But with that peak mixing, I think that cloud cover might be a little bit more overwhelming across the northwestern portion of Wisconsin up there. Let's now loop the surface dew points here with the HRRR. And you can see there's mixing happening. Bam! See those lighter blues pop out. And then later on, that front finally catches those 70 dew points a little bit off to the east, which could lead to a reinvigoration of that convection just a bit. So here is the SPC outlook with that slight risk. And the SPC did upgrade to a 5% tornado threat from northeastern Iowa into northwestern Wisconsin. And that slight risk extends all the way down into northern Missouri, but I do expect convective initiation all the way back south into eastern Kansas. And that greatest tornado threat, northeastern Iowa into northwestern Wisconsin, especially if the 3-kilometer NAM verifies. But if that HRRR model verifies and we don't quite realize that a strong instability or the near 70 dew points, and we do get a little bit more mixing as is depicted by the RAP and the HRRR. Even with that mixing, though, you still have 20-degree dew point spreads, which should yield more than sufficiently low cloud basis for a tornado threat. So my plan is to go live later on today and break down these severe weather warnings as they happen, break down the environment, break down that squall line as well, and those warnings. I'm going to have my eye out for tornado warnings, of course, and I'm going to be preparing for my varsity tutors class coming up on September 27 with that practice happening tomorrow. So thank you, everybody, for tuning in to my weather report this morning. And I'm excited to go live later on this afternoon and break down some of those tornado warnings later on today, severe thunderstorm warnings with that squall line moving through northwestern Wisconsin, back through central and eastern Iowa, maybe even into northern Missouri. So thank you, everybody. I do plan a Q&A session as well this evening for Facebook supporters only, and we try to do those every week. Hurricane Nicholas delayed that just a little bit, but if it weren't for Facebook supporters, I wouldn't be able to deliver these live briefings. I wouldn't be able to storm chase and deliver live streams because data is so expensive, and we wouldn't be doing our science as well. So as a special thank you to Facebook supporters, I am going to be doing a live Q&A tonight, our weekly live Q&A, 7 p.m. Central Time. Thank you, everybody. Never stop chasing.